Gábhíle sa cuaigdeag Páipéar hain ceist a chathair. So we're told that we have three complex numbers, Z1, Z2 and Z3, such that 2 over Z1 is equal to 1 over Z2 plus 1 over Z3, where Z2 is equal to 2 plus 3i and Z3 is 3 minus 2i. What we're asked to do is write Z1 in the form of a plus bi, where a and b are integers. So the first thing I'm going to do is just take out some of the key information. So the first thing I'm going to do is substitute Z2 and Z3 into the equation that I'm given. So I have 2 over Z1 is equal to 1 over 2 plus 3i plus 1 over 3 minus 2i. So it's clear that when dealing with this question, I have to deal with fractions and all the rules that are involved with fractions and complex numbers. So the first thing that I'm going to do is create a single fraction on the right hand side. Then it'll be easier to deal with 2 over Z1 on the left. There's a few different ways to approach this question. One way is you can just take each of these one at a time. So I'm going to do it that way first of all. If I have 1 over 2 plus 3i, we know that when we're dividing by complex numbers, we multiply above and below by the conjugate of the number on the bottom. So that's going to be multiplying above and below by 2 minus 3i. This is going to give us 2 minus 3i on the top. 2 by 2 gives us 4. 2 by minus 3 gives us minus 6i. We get plus 6i, and we get minus 9i squared. When we simplify this, it's going to give us 2 minus 3i all over 13. My plus and minus 6i are going to cancel each other out. My minus 9i squared is going to change to plus 9 because of my I squared. So 4 plus 9 will give me 13. Now I'm going to look at the second part of that right hand side. So I have 1 over 3 minus 2i. Now I'm going to multiply above and below by the conjugate of the bottom. So it's 3 plus 2i. So on the top, 3 plus 2i. And on the bottom, 3 by 3 gives us 9. We get plus 6i minus 6i minus 4i squared. So we get 3 plus 2i on the top. Again, plus 6i minus 6i cancel each other out. We get 9 plus 4 is 13. So one of the rules when dealing with fractions is that I can't add or subtract them unless they have the same common denominator. So by taking out the complex numbers and dividing 2 plus 3i into 1, therefore multiplying above and below by the conjugate, I've simplified to get 2 minus 3i over 13, and the same with 1 over 3 minus 2i. I simplified to get 3 plus 2i over 13. So now I'm going to substitute these two back in here. So we have 2 over Z1 is equal to 2 minus 3i over 13 plus 3 plus 2i over 13. Because I have the same denominator for both fractions, I can add the terms on the top. So I get 2 minus 3i plus 3 plus 2i all over 13. Which is going to give me 5 minus I over 13. We want to find Z1 in terms of A plus BI. So now what I'm going to do at this stage is say let Z1 be equal to A plus BI. So we have 2 over A plus BI is equal to 5 minus I over 13. So I'm going to multiply both sides by 13. So I get 13 multiplied by 2. Multiply both sides by A plus BI in order to get rid of the fractions. So I get A plus BI multiplied by 5 minus I. Now I multiply out my brackets. 26 is equal to 5a minus ai plus 5bi minus bi squared. I always know as soon as I have I squared in the situation, without even really doing anything else, I know I need to change that. So even if it's just writing it out again and changing that one thing, that's okay, just so we don't forget about it. So that'll change that to plus b. So in this situation, I have two different variables that I need to find. I need to find a and I need to find b. So what we're going to do is let the real parts be equal to real parts, imaginary parts be equal to imaginary parts. So on the left, 26 is real, 5a is real, and b is real. So I build a new equation. 26 is equal to 5a plus b. And then we do the same with the imaginary part. So on the left we don't have any imaginary, so I'll just leave that as 0. 0 is equal to minus ai, or minus a, because I'm just taking the numbers going with the imaginary parts, plus 5b. Now I have two equations. I'm looking for two variables, so I solve them simultaneously. I'm going to multiply the bottom line by 5. The top line stays at 26, 5a plus b stays at 0. I get minus 5a plus 25b. So 5a minus 5a just gets 0. 26 on the left. b plus 25b gives me 26b. So therefore b is going to be equal to 1. Now I know b equals 1. I choose either one of my equations. Let b be equal to 1 and I can find a. So we have a is equal to 5. So we said z1 is equal to a plus bi. So therefore we found that z1 is equal to 5 plus I.